everyone. All
Do I
right.
have to say hello?
Yeah, you can say hello.
Hello, everybody.
All right. So we're live today here from the Green School with a very special guest, Neil Thomas. And Neil is the founder and director of Atelier 1, which is an engineering firm based in the UK. And he's worked on structures all over the world and done some incredible engineering feats. So today we're going to look at this amazing building that's in front of us, which is the Arc. But first, before we actually get into the Arc, I want to ask you, Neil, how did you actually get into working with bamboo? What drew you to the material, and what was your first experience?
I run Atelier 1 for 30 odd years now, but discovered bamboo 14 years ago. But through the earlier part of running Atelier 1, we worked on stage sets. We still continue to do so, but we did a lot of stage sets for rock and roll bands like Pink Floyd, the Rolling Stones, U2. Now we're working on sets with Beyonce, that kind of thing. And the designer of those stage sets, the architect, we're structural engineers working with the architect, Mark Fisher. And about 15 years ago, Mark Fisher was dying. And he and I were very, very close. He wrote me an email with two things in it. It said, I wished we'd got drunk together a few more times and go and find John Hardy. And I had no reason, I had never heard of John Hardy before. I had no reason but for Mark. And because he'd asked, I found out where John was and I came to BalI. And I spent 3 days with John that quite frankly changed my life.
Oh, wow.
And it was this, I can tell you, I describe it to you. So imagine somebody says to you, I've been an engineer for 20 years, remember, at this point. And I worked with all the materials. Atelier 1 works in different materials. And we kind of work with new materials and developing kind of uses of new materials. 20 years in, somebody says, close your eyes, come with me, now open your eyes. And in front of you, what you will see is something that was always there, but you never saw it. And that was bamboo. And that changed my life. And that was it. And I've been coming ever since. To BalI, but to a lot more places where I work on bamboo, and we as an office Atelier 1 work with bamboo, yes.
And now you're here joining us for the 11-day course that's currently happening. And so that's really exciting.
One of my favorites. I love this. I mean, I'm very proud to say that actually I have taught at quite a number of places in the years I've been an engineer, including Yale in Connecticut, the Ivy League school, and MIT. And when I was asked to get involved with Bamboo U, it would have meant teaching at two ends of the earth, and I had to make a choice. And I'm very proud to say I chose to be here instead of teaching at Yale.
We're very glad that you're here as well.
No, well, as I said, I think this for me is a bamboo and Bamboo U, and what Bamboo U does is life-changing, and not for just me, a lot of people I've met along the way.
Yeah.
So
yeah, that's one of the ways I found about Bamboo U,
as I understand, yes.
So yeah, I took the online course and that's how I ended up here. So yeah, it's life-changing. And for those of you that are watching live, please pop in the chat and say hello. You can ask us questions through this little chat feature, and we'll go through your questions throughout the live as well. So let us know where you're joining in from and say hello. Alrighty, so let's talk about the Arc, because that's what we're here for today. We'll have other lives with you as well about other things, I promise.
Okay. But no, I'm happy to be here for this one. That's good.
And so this is the Arc as we see it, and it's made up of different arches that come together at certain points in the middle, and they kind of support each other. And there's also this grid shell in between, right? That kind of holds it together in tension. So can you tell us how it kind of works structurally? Like what makes it actually able to stand up? And
I can, but I think it's probably important to, if you agree, a little background to put into context how this developed, how it came about. So after seeing John that many years ago, he introduced me to his daughter, Elora Hardy, who runs IBUKU, the architectural design practice.
Yes.
And she was beginning to, I'd been working on bamboo buildings and done some quite amazing bamboo buildings, including Sharma Springs, which is one of the first I saw, which is one of the things that blew my mind.
Yeah.
But she was beginning to expand beyond the ability of the people she was working with. And when I say that, they're technical advisors, engineers, builders, the kind of thing they were doing. And they asked if we would get involved in, she asked if we would get involved in the engineering of their projects. But one of the things that's very important to us as an engineering practice, and I think really should be important to all engineers, is you're going to work with a material, understand it. And so we spent 3 years kind of looking into and understanding the bamboo and its nature, because being nature, it's very difficult, very complicated.
Yeah.
And so we looked at buildings they'd already engineered, and we kind of reanalyzed them, redesigned them, looked at them, so we understood what was going on.
Yeah.
So that was the first, and then that 3 years later, we started working with Alora, and we started working on small things, and particularly working on three-dimensional forms. We are, as a practice, interested in the idea of the kind of using minimum materials and shape in nature, and nature is a huge inspiration for us. Nature is very clever at making things with as little material as possible. So this is all developing forward. We're doing smaller things, developing bigger. In the meantime, I'm introduced to a man called Jorg Stam. Jorg Stam, who I've later kind of found out is probably the best, most knowledgeable person, the best builder of bamboo buildings ever in the world. And there came, so you put those three ingredients together, Alora and IBUKU, Jorg Stam, the builder and the most knowledgeable man and understanding of bamboo, and Atelier 1 engineers from the West who are interested in kind of nature and three-dimensional form. And the Green School had a gymnasium that had been there for 10 years and quite honestly was completely knackered and needed to be replaced. It was a tin shed on bamboo structure. And so the idea came along and we agreed, well, not agreed, we jumped to the opportunity to be involved, not only with Alora, but side by side with Jorg Stam. And Jorg built a few models, which were a series of kind of arches and then a series of crossed arches, much like the form it is now, but it kind of started as a series of basic arches. And we talked about using membrane structures, fabric structures, to link the arches together and create this three-dimensional form.
Okay.
But it became clear very quickly that membrane wasn't really appropriate.
Okay.
And we had been in the development work with Alora at the time, looking at taking bamboo columns and splitting them down into small sections and creating shell surfaces. So I use the word shell, it's nature.
Yes.
All shells that you see in nature, they're very thin forms, but they use their shape to make them strong. So we were approaching the design in the same way. So this is a kind of really, truly collaborative project between IBUKU, Jorg, and Atelier 1. And it evolved into the shape you see today, which is, interestingly, I mean, you described it correctly. It's a series of crossed arches. They're parabolic in form.
Yeah.
I mean, that's if you take a chain and hang it, it will form a parabola. And so you take that chain and reverse it, and it's so parabola in compression. But it combines together with the split surfaces, the three-dimensional surfaces, and they interact with the arches and stabilize them. One place where you could see this very, very clearly is in the wing of a fruit bat.
Okay.
The fruit bat has got incredibly thin bones, really ridiculously thin, and it's made possible by the shape of the skin of the wing between it. So if after this, you take a look at a picture of a fruit bat, you'll see where the inspiration or part of it came from, the idea of these three-dimensional surfaces stabilizing the arches. And so this thing is one object, and it breathes like an object. So it's like ribs and the muscles between ribs. So all materials are elastic, it kind of moves in and out. So when it takes load, it changes shape slightly and redistributes the load. I mean, the history of where these things all came from goes back to Fry Otto from Germany, who formed the Institute of Lightweight Structures, from the work of Felix Candela in Mexico, the shell builder. There's a kind of whole history of people you could refer to. And as these things are kind of moving forward, we drew from as inspiration. But I would say fundamentally nature is its most foremost inspiration.
And so then, like you mentioned with the bat wing, for example, these arches are kind of the thin kind of bones, if you'd so call them.
Exactly.
And then this structure in between, which is the grid shell, like you mentioned, the shells, that holds it together in place. And oh, wow.
But it is a combination of the two.
Of both.
They don't, well, quite often, if you look in buildings, they work in a hierarchical way, where one piece of structure sits on another piece and then sits on another piece, and it transfers the load down to the ground. This works as one.
That's really interesting.
So we were very fortunate to be able to work with, as I said, Jürgen and Ilora. One of the kind of prerequisites is that we worked with the foundations of the existing building, which is great for the...
So all these ones are like the...
They are the original foundations from the original building built 15 years before, or something like that.
Oh, wow.
Which is great for the sustainability story, because we were reusing. Regenerative architecture, regenerative engineering is a very important thing in the kind of world of climate change, because we need to think about whether we can reuse, repurpose buildings rather than simply knock them down and build again. Because the building industry that I work in, and we are anything you sat in, is 40% of greenhouse gases in 40% that are produced on the planet. So the more we can do to change the way buildings are done, and bamboo is a wonderful starting point to do that.
Yes.
You know, we can reduce the amount of emissions and improve our chances of not overheating the planet to the point where it's unusable.
Yeah, it's true. And so you mentioned that you used the existing foundations that were already there. I can imagine that was probably quite challenging, was it?
Yeah. It's very challenging. Because generally you would probably design the form of something, and then you would carry the, obviously it depends upon the site limitations and restrictions, whatever, but generally you design the kind of idea of the form of it and the foundations would follow. And then but this way we had to think about that from the foundations up. But I think if I'm absolutely clear and honest about it, it was Jorg's positioning of the arches, or his model he built of the arches. We didn't need to do a lot to move the model he made around so that it lined up with we did have to alter it. It tapers in at either end, which it hadn't in his original model. But it wasn't a huge amount of work to do that. And in fact, the tapered form, interestingly, was better for load carrying. So all of the kind of things that evolved and developed out of the use of what was already there were ultimately beneficial.
Yeah, it all worked out, I guess, right?
I think it worked out pretty well, personally.
Yeah, it worked out really well. Yeah, and I mean, it's an incredible building as well. So
I mean, it won awards. Do I talk about that now?
Yeah, definitely.
So after it was built, the things you have to understand that the whole building is bamboo. There's very little else in it at all. And so we, having the offices of Atelier 1 are in the UK, in London, and we entered it for the Institution of Structural Engineers Award in 2023, which it won for sustainability.
Wow.
But the great, wonderful thing was then it went on, and they take all the awards they've given, they choose one, and it won the Supreme Award that year. So it won the ultimate accolade, which was really we're obviously very, very proud of it.
Yeah.
They said sustainably, they said they'd never seen anything like it. It was off the scale in terms of its sustainability.
Yeah.
Because basically, if you imagine, we haven't built new foundations, no concrete we've used, it's existing stuff. And the bamboo grows somewhere over here, I don't know, somewhere
nearby, not too far.
So you cut the bamboo down, treat it, and then you build it. So it's hard to kind of beat that as a story for for sequestration of carbon, because the bamboo grows very quickly and sequesters carbon, which is a great argument for that. But also in terms of emissions in both its construction and in its operation, which are the three things we really need to think very hard about when we're designing buildings. So that's embodied carbon, carbon in the construction process, and operational carbon.
Were there other challenges that you think
you have no idea?
What other challenges did
Well,
you
the
guys
thing
face?
about it is,
Because it was, I mean, I think from what I've heard at least, that there hasn't really been any other structure like it that's been built, right? It's pretty big. It's like 14-meter tall arches that span 19 meters across, right? So it's a pretty big bamboo building,
it's
one of
very
the
big.
biggest.
But I think obviously we had the good fortune that the gym had to meet certain requirements for use for volleyball,
Yeah.
badminton, etc. So
Yeah.
certain volumes we had to meet. So it had to be of a certain scale. So immediately that's a. But I think it is, I would say that it's a kind of culmination of ideas that have been developing for years now. Remember, this is 2021, was it complete? 2021?
Yes, 2021.
And so we'd been working with bamboo at this point for 7 or 8 years.
Yeah.
And through that period, I had begun to learn. And really, when I say begun to learn, I mean begun to learn. You'd think after that period, we'd have a pretty good understanding. Well, we're still doing it now. 2025, we're still learning, and we will go on learning. But so there are certain lessons we've learned, but because of the scale of it and some of the things we were doing, like the split grid shells, so the splits being the bamboo cut down into small splits, they are formed from doubly curved surfaces. And at this scale had not really been done before. So the bamboo arches, to span the size they need to go in their form, they needed to be bundled together. So in fact, some of them are 6 columns combined together to form a single arch. And because that hadn't been done to do it, it meant that there was a whole another process of testing materials, composite action of structures, so the combination of the bamboo columns to form the arches, the grid shells. The grid shells are formed as roughly orthogonal or square, you could say, although they're not square in shape individually. But the point about that is it has no stiffness in the plane of the roof. So we had to add that stiffness to make it strong. That was done by adding a bamboo unfolded into a flat plate. But again, so we were relying upon the translation of a force through one thing into another that we needed to test. None of these things have been tested. And if there wasn't, the wonderful thing was they were completely understanding of this, and it was a lot of money to do all the testing associated with it. But I think you wouldn't argue it paid off. And it's testing that we've gone on to use the information from. When I began working in bamboo, there were only 2 codes of practice at the time, the Colombian code and the Chinese code. And now today, the ISO standards that we are involved in writing because of the expertise we've developed over many years of working with bamboo. So we have a colleague at Atelier 1 who he sits on the ISO committee. So we are involved and we get to kind of review all the standards for bamboo in its natural form.
That's awesome. Yeah.
Yeah, I mean, it's pretty good to be able to be involved in the kind of expanding understanding of a material which I am absolutely convinced in my lifetime will be a part of the Western, not just the kind of, people always ask me about, is it just, can you only use it in the tropics? The answer is no. In various forms, it will become part of the Western industrialized construction industry in my lifetime. I'm absolutely convinced of it.
In what ways do you think? What specifically?
Can I tell that?
Yeah.
Oh, it wasn't. It's not a secret.
No.
No, but the Chinese have been working with bamboo. I mean, China's covered in bamboo, right?
Yeah.
They use a lot of the bamboo that's used is called Dendrocalamus asper. That's the kind of main structural one. I mean, there's 1,600 species of bamboo, and there are half a dozen, 10 which are used regularly in structural design, the structural element of buildings. And in China, it's most so.
Yes.
Indonesia, asper, Dendrocalamus asper, and when you go far to South America, guadua is the kind of the primary ones. But the Chinese have been building with bamboo for a very, very long time. And very recently, they completed a 6-story building, full 6-story building at a university in China, built from engineered bamboo. And engineered bamboo is like timber. In timber, when you take a tree, chop it down, and you can build it into glue laminated beams, the same process you can do with bamboo. And there are various processes you go through. but ultimately you achieve the same end. It's a glue laminated bamboo section. So you can build similar things to the things that you can do as everybody sees in timber, you know, regularly. So yeah, and that's fairly embryonic in its development.
Yeah.
As I said, the Chinese are doing it. As far as I'm aware, there are very few buildings elsewhere that are built from engineered bamboo, but they will become more and more and more. I'm absolutely sure of it.
Yeah, that would be really exciting because right now we see a lot of it used in the tropics mainly, like for example here in Bali, of course, and there's other tropical countries where our followers are based and stuff like that, where bamboo is now starting to gain speed. But yeah, it'd be interesting to see how it actually takes more form in the West because that's also where a lot of our followers are based, and that's one place where we see a lot of construction with materials that aren't always the best for the environment.
And I think it's something, I mean, the opportunity to speak like this, it's something we as engineers, but we all as designers, architects like yourself, the bamboo you, but everybody beyond, right? We all know we're living in a world that we're really, you know, we're fucking up basically, and we need to do something about it.
Yeah.
And to change the construction industry, we need to work with natural materials, amongst other things, or change construction processes. And bamboo is one of those materials. And to all those people who come to me and say, well, bamboo's not, they don't want us to replace timber with bamboo. Let's be clear. Bamboo is not timber, and it's not competition. They're complementary materials.
Yeah.
If we can add bamboo, and the thing is, there are countries around the world, like the French recently have said by 2030, that's in 5 years' time, 2030, 50% of their public buildings will be built from wood. Oh, wow. Natural materials. They didn't say specifically wood. Bamboo is not, by the way, wood. People who describe it as timber, it's not timber, it's not wood, it's a grass. Yeah. And please, to differentiate and be clear about it, this bamboo is a grass. Yeah. So when you describe it, please don't describe it as bamboo timber or bamboo wood.
Yeah,
it's confusing. Yeah. And so the thing is, the enormous volume of bamboo that's grown throughout the world, once it's processed, even that processing means that it's still very, very good material for use in buildings to A, sequester carbon, and B, in terms of emissions, reduce the amount of emissions. So it's a fantastic argument for using this material. And recently in Washington, D.C., a building was built. This is about timber, but the principle remains the same. Because previously, you were not allowed to take account of sequestered carbon in the carbon calculation for buildings with natural materials. The argument being is at the end of their life, you could set them, light to them, and all the carbon's back in the atmosphere. But recently, there was a precedent set. Building in Washington, D.C. was approved for exactly that, which is a big deal for the timber industry and the bamboo industry in terms of showing just how much better it is, how much better these materials are than others like concrete and steel. And let's remember, there's an enormous amount of energy used and carbon and greenhouse gases produced in the manufacture of those materials. Timber and bamboo is from nature, and it's sequestering carbon. It takes CO2, the very thing we're trying to get rid of, and it takes it up for photosynthesis and gives you carbon sequestered back. So, I mean, we must be pursuing these materials. We must be.
Alrighty, so we have a couple questions in the chat. We have one from Sarah, who actually attended our course a few months ago. I think you might have met her in August last year. But she's asking, Neil, would you please elaborate on the structural analysis of the grid shells specifically? Is the behavior the same when using poles and bamboo splits?
Thanks, Sarah. That's quite a difficult question to answer, and the first one. So thank you very much for that. Arches work that they support load. So we have to design the structure for both wind load and here in Bali for earthquake. And you are resisting what are basically horizontal forces. And arches are pretty good at transferring forces, gravity forces down, but because the loads are relatively low. They're also not bad, but you're doing it in the stiffness of the arch, the strength of the arch. So you have a very stiff thing, this arch.
Yeah.
I mean, I know I'm not supposed to do this, but I'm going to do it anyway.
Yeah, you can see
so
it. Yeah.
this is the arch, and it's quite strong, but it kind of wants to buckle, right? And so the arches combine together, that they lean over and into each other. That means they're reducing the length of the buckling of the individual arches, which is very clever. This is Jorg's idea, right? Jorg Stamps. And then, because they're very slender elements, what we do by attaching the anticlastic surfaces, they're called these surfaces you see in the model here in front of you.
The doubly curved ones, yeah.
They are resisting force. So as you press down on this, the surface this direction carries the load like a cable, a hanging cable in tension. And then when you get uplift due to wind, it's in tension in the other direction. So it's a two-directional load carrying device. And it's very clever, and developed. Nature did know. I mean, nature's been doing it for a million years or millions of years, but it's been developed, and Friarto had an enormous amount of involvement in the development of how to use and understand those kinds of structures.
Awesome. And so, is this behavior the same when using poles or bamboo splits? If you make a grid shell, I guess.
So the arches are obviously using bamboo columns in poles, but they are bent into shape. And there's a technique used here in this, which I am not particularly a fan of. And in fact, I would think in future will refuse to work on a project that uses it.
Yeah.
It's called reb here in BalI. And it's a technique where you take a pole. Poles are like any other tubular structure that it will. So if this is you can see this piece of paper has no stiffness.
Yeah, it's floppy.
But if I roll it into this, you can see it's formed a tube. That tube can now carry load. Oh, well, not very much actually.
It's because it's a piece of paper.
But it carries load.
Yeah.
And I haven't done anything to the material except change its shape. That's a bamboo column. So what we do is then, that carries load through that stiffness, the shape of it, and obviously the material strength. And then to bend it into shape, to form the curve, what they do is they cut the bamboo through and then fold it, which is insanity, actually. Nature's grown this absolutely remarkable piece of structure, stunningly beautiful. So, I mean, if I could talk about it in more detail, I would explain just the reasons why bamboo is so incredible. But it's very hard to do without being able to show you. So it folds it into place, and then we have to reinforce the bit we've cut. So we take a perfectly good working piece of something, cut it, close it up, and then have to reinforce it to make it like it was before you bent it. But that's the price you pay to be able to bend it.
Yeah.
We now know a lot more about bamboo in the years we've done, and now we know ways of bending it that are different, which means we don't have to cut it.
Yeah.
So poles will carry load like that, and that's the kind of normal use. So an arch is like a curved shaped pole. Sarah, I hope that answers your question.
And she has another question.
Oh, Sarah.
Sarah's asking a lot of questions. Sarah's an engineer.
Oh, is she really?
Yes,
No surprise.
And then she's also asking, how did you address shear forces in the connections?
So Sarah must have seen my talk, right?
Yes.
That I do at Bamboo U,
Yes.
which is why I'm here in BalI for Bamboo U course to do a talk today and tomorrow. And the one thing I mentioned about learning about the particular materials when we work with the material, one thing we learned very early on is that bamboo is very poor in shear force. Anybody who doesn't understand what shear force is, if you take a pack of cards and push half the pack, the point at which it begins to slide means you've overcome the shear between one set of the cards and the other. That's the force, that's the shear force. But bamboo grows, and again, to be very clear, distinguishing it from timber, when timber grows, it starts very small and it grows up and out, which is why you see rings when you cut a piece of bamboo, a tree through. And those rings are very important to the shear strength because they form a ring around the whole surface, and that's giving you the shear capacity, amongst a number of other things, but that's the fundamental thing. Bamboo is interesting in that it doesn't grow upwards and outwards. It grows full size from the rhizome straight up. And in growing straight up at full diameter, what is happening is you get the longitudinal fibers, which are the technical fibers that carry the load. They are incredibly strong. Those fibers are connected together by a kind of glue, which is called parenchyma. But that glue has almost no shear stiffness. So, which is why it is an interesting thing, because it gives you the wonderful property that you can split it, but at the same time, it means it's very weak in taking connections. So, if you put bolts through it, you will likely split it if you overload if you put too much force through the bolt. So, one of the things we've been doing in more recent years is developing connection systems that work with the understanding of those properties. Because it's very easy to kind of fall into the trap of saying, oh, it's very poor in shear. But it's not, it's just different. It's nature. Nature does it. I mean, it's unbelievable. These things grow 30 meters tall and stand there in the big winds, and they're perfectly fine. They're happy, right? So as engineers, you need to kind of embrace the idea of what it is and see the positive in it. Not go, oh, it's really crap. It's not. It's just different. So once you understand it's different and you know those differences, you can do things with those differences. And so it's led to, interestingly, a completely novel set of connections, which I cannot talk about, by the way. So Sarah, don't ask me what the connections are. I can't tell you.
All right, see. And so for this building specifically, what were some of the tests that you had to do? Because you mentioned we had to do a lot of testing, right, to actually make sure that it would work. So can you talk about some of the tests?
Yeah, of course. So if you imagine the structure is built of a series of components. So the shells themselves, the anticlastic surfaces, which means opposed curvature, by the way, negative and positive curvatures. So, like this. So a dome is synclastic because it's got two positive curves, and this thing is a saddle surface is anticlastic. Remember I mentioned that we added the flattened bamboo to create the shear surface above, and then that sits on the splits. We had to take that shear surface and understand how much force it could transfer. So we had to build mock-ups of the shells themselves and slide them over one another to see that. The splits themselves, they are hanging in tension, so we need to know how much each individual split can carry. So we did a bunch of tests on that. The connections between the splits, testing those. And then unbelievably, they went on and built a full section of the roof, complete section of the roof, arches and grid shell combined, and we were able to test it for conditions that it would see when it was in its final place, which is interesting, because when the wind blows on this is, if you imagine this, the windward side of a building, this is called the leeward side, the opposite side. The wind blows this way. And so how do you test that in big form? So what we did was we put some hangers on this side, and on the other side a bunch of people pulling ropes.
Oh wow!
So and this is the
try
point.
Something.
I mean, you can. I mean, I think engineers sometimes can be also conservative in the way they look at doing these things. You have to have some understanding of it. And a lab test to do that would probably cost as much as the building costs to do. So we did what was possible here, and that's the amazing thing. Is the craftsmen were able to build these things very quickly. They were able to set them up and test them very quickly, and the people here were very willing, and actually people were very excited. And so we went through that sequence. The shells, the arches formed from bundles. We tested the individual bamboo column for all its forces, compression, tension, shear, bending, and then we combined a couple of them together and showed how they connect together, because there are two ways of connecting. One where you just combine each individual one and its equivalent structure, but if you can combine it in a way where they become composite, then the strength increases more than the doubling of the number. So And we continued. There were more and more and more tests, but
lots of them.
They were absolutely amazing. Yeah, it was beautifully. The thing is, I think no test, at no point did they ever kind of say, "Look, we can't do this." They understood and recognized what they were doing here.
Yeah.
They understood and recognized we were pushing stuff together as a team, as a group, and the Green School themselves. You know, they understood all that.
Yeah.
And so it was necessary, but people saw the potential, and so were willing to support all of those. Had we not done those tests, we would never have been able to build it. We couldn't, or confidently build it.
Yeah, that's true. Yeah, and I like that you mentioned that you used the resources that you had available in this area to actually do those tests.
Anything. Right? I mean, they. So I probably ought to give a shout out to James Wolfe, who was a guy who lives in North America and came here, and he ran all the testing.
Wow.
And the important thing when you do testing, whatever the kind of nature of the test, is you record information very, very carefully and very rigorously. Otherwise, the testing is pointless.
Yeah.
So I think he was brought on to do that, and he did just that.
Yeah.
And we refer back to that testing obviously today, but so if you're testing a big combined set of columns, they just to load it. I mean, we have to set up the test. There are recognized ways of testing. They had to vaguely be in line with the recognized ways of testing, but they would bring anything along, so a bunch of stones or a bunch of blocks, and as long as we knew the weight, that was fine. It didn't have to be measured weights because we were there or thereabouts. We were testing the principles of things and getting an order of magnitude of strength change, you know, what we could achieve with it. And trying to do it, sometimes you have to have a very clear perspective of what you're doing. And what we were doing is to try to understand how it was working. And the numbers, although important, they are not really the critical. An order of magnitude, right? Fine, I understand. But doing things to decimal places is ridiculous. It's just never, it's just pointless. Absolutely a waste of time.
Interesting. All right. So I have one very final question for you. And if there are any that pop up in the chat in the next few moments, we'll take them as well. But what innovations or trends that are bamboo related are the most exciting to you right now?
Okay, there are, it's interesting. So the first thing I would say is the education of the understanding of bamboo is the first, is very important. In terms of materiality and what's happening with bamboo, so I mentioned two processes of breaking the bamboo down to form it into laminated sections.
Yes.
And there's the one where you take the splits and machine them into rectangles and combine them together to form beams. So you form a plank, and then you add a plank to another plank and you create a beam. But there's another process which is called strand woven bamboo, or often known as scrimba. Scrimba. Yeah. Where you break them down even further. You crush the bamboo basically, because remember the longitudinal fibers are doing the work.
Yes.
And it separates the kind of parenchyma from the fibers. So you end up with a bunch of fibers. And then you combine them with glue and compress them and form densified bamboo. That's an interesting idea, but it's intensive in terms of the need for resins to glue it together. But okay, people are developing, or bio-resins are being developed.
Yes.
So glue laminated bamboo in either its kind of normal laminated or strand woven forms, both interesting, both being developed. So that's happening. I mentioned the fibers. So you can take the reduction to fibers further, where you remove all of the parenchyma from the fibers by treatments.
Oh, wow.
And you end up just purely with fibers.
Okay.
Now that we're talking something else. Bamboo fiber is remarkable.
Yes.
I mean, I explained to you that I run an engineering office. We don't only do bamboo. We started doing bamboo 14, 15 years ago, but we do a whole lot of other stuff.
Yeah.
And I mentioned my introduction to John Hardy was through Mark Fisher. U2, we worked with U2 5 years ago on a new set for them, where the whole of the structure of the LED screen was built from carbon fiber.
Yes.
Carbon fiber composite. Okay. Now, you have bamboo fiber and carbon fiber. carbon fiber and bamboo fiber are not so dissimilar in their strengths. Carbon fiber is a bit more, but here's the interesting thing: bamboo is lighter, and it's natural. And so, can bamboo fiber composites? Bamboo fiber based composites are being used for wind turbines today, and because the fibers are lighter, and it's significantly, it means that bamboo, the blades can be made slightly longer than if they were in carbon fiber. And so, interesting, let's make a point. People sometimes call bamboo vegetable steel. It's not really vegetable steel, it's vegetable carbon fiber. It's like, it's a fibrous, you lay it up, it's not isotropic, the properties are different. So don't think of it as steel. Think of it as it's a very strong material. You shouldn't call it anything really, but if you had to, bamboo carbon fiber is good. So composites in wind turbines, then just composites generally. And I mentioned earlier on the connector system I'm not allowed to talk about. I'm not allowed to talk about is carbon fiber. Is bamboo fiber composites using to form connections in bamboo, which account for the variation in properties of the bamboos themselves. And so, because when you cut a series of columns, no column is the same. They are not really quite circular. They are elliptical, slightly in a section. And if you're interested in why that's like that, there's a book by a man called Peter Volberen called The Hidden Life of Trees. Because again, I've made the point, they're not the same material. Bamboo is a grass and tree, but how they grow and why they grow like they do, there are certain things the same in trees, and why no tree is circular, it's elliptical. And it's to do with the kind of the prevailing wind directions. They have to be stiffer in one direction. And so that's why they're slightly not circular. So the point is, bamboo columns are not circular. They're not necessarily round, in even symmetric in an elliptical form. They are different sizes at either end. The column is tapered up to the top. So when I bring two bamboos together, inevitably they're not going to be the same. So all of the considerations of connections need to be based upon the fact that actually there's this kind of nature. You're dealing with nature, and you need how nature is never going to. If I have a 10 centimeter piece of steel over here and a 10 centimeter piece of steel over here, when they put them together, they're the same, right?
Exactly.
That's not true with bamboo. So you need to think about it in a different way. But as I said, that's the kind of joy in it, really. The fun is finding the solution that deals with the kind of the various properties it does have, and some of those being mechanical properties, some of those being geometric properties.
And actually, one last question that I just thought of.
Okay.
What advice do you have for engineers that are wanting to learn more about bamboo or are thinking about working with bamboo, but they're not sure? Do you have any advice?
Well, right this moment, there are not very many places in the world, I think hardly none probably, like where I am sat right now, BambuU, which runs this course every 3 or 4 months. I think I come to as many as I can, and come and talk about the engineering of bamboo. And each time, and I have interesting updates to give this time that have not been seen before. So I'm very excited about that.
That's awesome.
It's nice to come along with something a little new. And but I would recommend you perhaps, if you're already talking to bamboo, you go and find as much information from wherever. The bamboo world is an incredibly generous world in spirit. It is the friendliest world I've ever worked in building, and I think it's to do with working with nature. I think it's just, you can tell. But once you get involved with bamboo, it's a disease, I promise you, which you never get rid of. You're done. You are hooked, and everybody I know who's ever got involved is hooked. We have a lot of people now in the UK. And I go back here, from here, Jorg Stam and I are talking in the middle of England, Stoke, on Trent, in the middle, where the summers are 25 degrees and the winters are -10 degrees. And bamboo doesn't grow very well. Doesn't matter. Bamboo is growing, expanding as a thing that people are interested in. But connect with people. A lot of people out there doing this stuff around the world, and they are very generous and very open to conversation. And I think BambuU certainly gives you access to a lot of information. I don't see everything that comes out. I mean, otherwise I'd do nothing else. But I do watch what I can. So it's interesting. And if there's something particularly interesting, what I like about the BambuU course, I might say, I come along for a couple of days, spend an hour or two, a couple of hours each day giving a talk, and then I might get involved in the design of something if something's going on, if they're building a particular project. But afterwards, I keep all of the WhatsApp groups that are set up in each BambuU are continuing for life as far as I can see, because everyone, I don't know what number we're on today, 25 or something?
Yeah, we've had,
I think.
I don't even remember.
But all of these groups still continue to communicate with each other. And if I catch something occasionally from somewhere from a group 5 years ago that is interesting, then I'll get back in touch, because I can't be, again, I've just spent all my time on WhatsApp groups and BambuU, which I, much as I'd love to, I haven't got the time. So communicate, I think, is the important thing. If you're interested, just ask people, because inevitably they will be open to conversation, and it's what I find. And like I said, it's a very generous world, so, and one I'm very happy to be a part of, and happy to be here. And I hope I continue to get invited back to come and talk at BambuU.
For now, I think so.
Okay, no, for now it's good. For now it's good.
No, we're really happy to have you here, both for this YouTube live and in general when you come and support us at BambuU courses and even online. So we're really, really grateful to you.
No, it's absolute. I can't tell you, it's a pleasure. A pleasure.
All right. Well, thank you again, Neil, for being here.
Thank you very much for asking me. I've enjoyed it. Thank you.
And thanks everyone who was watching live and sent in comments and questions. We're really grateful for that too. Be sure to subscribe to our channel, because we have a lot more that's coming up, and we'll see you next time. Bye, everyone.
Thank you very much. Bye-bye, everyone. Bye, Sarah.